everyone. I guess I am the final boss before lunch, so we'll try and make this good. So hello, I'm Lauren. I'm an engineer on the React team, and I work on the compiler. And before we start, to keep things a little fun, I have a small request. So I hope you all can, fulfill my request. And my slides went away again. So my small request is, I have a bottle of water here, and it's really important to stay hydrated. So I'd really appreciate if every time I take a sip of water, y'all could give me a clap. Should we try it? While they fix the slides, yeah. So thank you for that. I think I might be a little thirsty during this demo and talk. Should we give a round of applause as well for the staff for helping us? OK, there you go. All right, so let's get started. So earlier today, you heard from Joe that we open sourced the React compiler as an experimental release. And you saw Mofe and Sathya tell you about how it works and how it performs at Meta on large and really heavily optimized apps like Instagram.com. So rolling out to Meta apps took us weeks and months, but we only have 30 minutes together today, and we're all hungry. So I want to show you how you can adopt the compiler with very little effort. So we're going to look at what it's like to add the compiler to your app, what it feels like to write new code of it, and build some intuition for what the compiler does. So to do that, let's add the compiler to a real open source app, Blue Sky. Now, if you're not familiar with Blue Sky, it's a decentralized alternative to Twitter, and it's built with React. And I asked someone who works there, and Blue Sky already has a pretty good amount of manual memoization already. So I'm not expecting that we make it way faster, but I think we can make it much easier to maintain performance and write better React along the way. So let's get started. All right. So I already have Blue Sky running in 2 tabs in my browser. So on the left, you can see that the compiler is enabled with the green circle emoji. And on the right, the compiler is disabled with the red circle emoji. I also have the app open in my iOS simulator. So the first thing I want to highlight about the compiler is that it works on all platforms. So Blue Sky is an Expo app. And if you've never used that before, Expo is a really great way to build a React app that works on all platforms. And that's really nice because when I set up the compiler here today, it's just going to work on all these platforms. So that's really cool. But to make the demo easier, I'll just use the web version. OK, so the first thing we want to do is to install the compiler. And as you saw earlier in the keynote, starting today, we can install the compiler from npm and update our Babel config to add the compiler. And I've already installed the plugin using npm install Babel plugin React compiler, and I've also added it to our Babel config. So let me show you what that looks like. So as you can see, it's not a lot of code. And don't worry about writing this or even reading this. We have a lot of detailed instructions in our docs on how to get the compiler set up. And I'm going to link to that later. So now that the compiler is installed and we have Babel set up, the second thing we need to do is run our app and confirm that the compiler is running and optimizing our app. So as I mentioned, I already have Blue Sky running. If you can see compiler left, not compiler on the right. So I want to just click around a little bit on the compiler version and just double check that it all works. So let's just jump around. Maybe even write a tweet. A post, sorry, not a tweet. I love use Memo. Cool, that works. Very nice. So it looks like the app still works. But one thing we found through rolling out the compiler at Meta is that for debugging purposes, it can be really useful to tell if the compiler is enabled or not But obviously, you don't want to add an emoji to your app. So one way that we recommend is to actually look at the React DevTools. Uh-oh. There you go. So the first thing you'll see in the React DevTools is there's a whole bunch of these blue sparkly badges. And that tells you that the compiler has automatically memoized this component. And that's really great. And let's just double check on the right that we don't have any badges. There you go. So yeah, on the right, we have the compiler is actually disabled. All right, great. So we've installed the compiler. We have added it to our Babel pipeline. We've confirmed that it works through the DevTools. And then we did a quick check to confirm that the app still works. But how do we know that it actually did something or anything? Did it actually optimize, or did it just skip over stuff? So one way you can do this is, to open your console, look at the sources tab and the stable source maps, and look through the compiled code and try to see what would happen. But that's really annoying to do. So let's go back to our editor and see if we can learn just a little something about what the compiler is doing to optimize our app. So to do that, I'm going to look through the lens of a component called the post controls component. So that's this row of buttons at the bottom of each post, so you can reply to a post, repost a post, and also like a post. So let's go take a look at that. Post controls. OK. So to better understand what the compiler is doing, I hacked on a little small IDE extension just for this demo. And this isn't the official VS Code extension for the compiler, but it's just something to help me show you what the compiler is doing better. But actually, through building this, it's given us some new ideas on what an official VS Code experience could look like. So that's pretty cool. So let's take a look and see what the compiler has done to optimize this component. So there's a whole bunch of code on the right, so don't feel like you need to read it all. But this essentially shows you what the compiler has compiled. So one way to tell if a component or hook was optimized by the compiler is to look for this little $sign variable up top. And don't worry about how to use this. It's not meant to be used directly. It's really just for the compiler. So one way you can think about this is it's just a big array of values that the compiler can use to cache and retrieve values efficiently. We can also see, if I scroll down a little bit on the left, that the compiler, as much as possible, preserves the original code as it was written. So when you're debugging, you can look through this and it looks familiar. But it does do optimization. So it's just a little bit harder to read. There's a whole bunch of $signs everywhere, and there's these kind of hard to read if conditions. So that's OK, because there's a better way to understand it. So I'm going to close this panel real quick and do that. So I added another view to my little bootleg IDE extension to just help me see at a glance what the compiler is doing. So the first thing you'll see is there is this sparkly emoji next to the component name. And just like the React DevTools, this tells you this component has been auto-memoized by the React compiler. We also have these dep labels, which is short for dependency. And that means that this value is a dependency of some other value. So that means that when these dependencies change, the output values that require these dependencies will also update. And then if I scroll down a little bit more, you'll also see, where is it? This RTV reactive label. And that tells you that this value depends on one of those, or one or more of those dependencies that we just saw earlier in the code. So I want to take a look at this variable a little bit, just so we can dive a little bit deeper here. So if I hover over this value, you can see that the compiler says it's reactive, or it depends on theme.palette.default.postControl, which makes sense, right? Because again, this is the post controls component, which is the row of buttons at the bottom of each post. We want to make sure that depending on the theme that we have chosen or selected, that the correct colors are used. The default control color is also a dependency, which is pretty interesting. And that's because it's used later on in the JSX to determine the correct colors for the buttons. But here's something also interesting. This variable and value has been already manually memoized with React.useMemo. But the really interesting part is here in the dependency array, because originally we wrote this as just depending on the theme object. But the compiler says it's not the theme object, it's theme.palette.default.postControl. So let's look at the JS output again, just so we can understand what's going on. So let me scroll down and find this. That's over here. So the first thing you can see is the compiler has removed the manual memoization. You don't see use memo here at all. And if you look at the if condition, this check over here, you can see that it lines up with the what this value depends on. So this condition tells you what this block of memoization depends on. And as I mentioned, it's different from what we've specified in the manual memoization because the compiler has figured out that we can just depend on the property changing and not the entire theme object changing, which you can imagine might just change a little bit more frequently. So this is a really small example, but it shows you that the compiler has memoized this more granularly than we often do by hand. And the same will go for the rest of the component. The compiler will figure out exactly what needs to be memoized and what they need to depend on. So the second key thing to remember about the compiler is that it can granularly memoize much more efficiently than we can. Computers, it turns out, are way better at this type of granular tracking and optimization that we are. OK, so now we have a little bit of an idea what the compiler is doing. We know that it looks through our code, it figures out what the dependencies are, and then it memoizes values such that they only change when the dependencies that actually affect it change. So now I want to take a look at what it feels like to add new code with the compiler. So let me turn everything off. So the feature I want to add is going to be on this post controls component, which is, as a reminder again, is like this row of buttons here. So let me back to my profile. So sometimes, when I look at my timeline and I see something that someone posted that I just disagree with, like this post right here, I secretly want to dislike that post. So I kind of want to add that feature as a local-only thing, so I can dislike posts in private without anyone else knowing. Just to feel something in my cold, dead heart. So let's add a dislike button to the post controls. All right, so let's go down to the JSX. So there's a lot of JSX here, but this is essentially a big block of code for the like button. So what I want to do is just add the dislike button right next to it. So I've already prepared something here, and remember to save. So if you've never seen this before, the view component is from React Native Web, and that allows this code to run on both web and mobile. And if we click on the dislike button, it doesn't return anything right now, so we have to implement it. So first of all, I already have some theme variables prepared, just so it looks good. So let me just paste those in. And just like the post controls, this just makes sure that depending on the theme that's chosen, we use the correct colors. We also need to return some JSX. And again, this looks like a lot of code, but really it's a button that wraps an icon, a thumbs down icon, and some text that shows you the dislike count. So it looks like a lot, but this is really good because it has a lot of good stuff like accessibility, and the compiler can just handle all of this, right? Even though it looks complicated. So the first thing we got to think about is, all right, we want to dislike post, so how do we do that? So we know that we need some state, right, to increment whenever we click on this button. So let's just add that. And then we'll initialize it to 0. So we have a dislike count and a set dislike count. So on our onPress handler, we'll just set the dislike count to be whatever the count is plus 1. And then we'll save and go back to our browser, refresh. And we can see, hooray, now we can dislike this post. I love use Memo. This person is so wrong. OK, so we can see that this works. And cool, are we done? No. You see, now that I've added it, I don't really like it. You see, the thing that I dislike more than posts like this is unnecessary rendering. It keeps me up at night every time a button re-renders, right? I'm raging inside. Anybody else hate unnecessary rendering? So what I want to do is I want to make this dislike count automatically go up whenever the button re-renders. But I also still want to be able to click on it just to, express my anger. So let's build this. Thank you, thank you. All right. Wow, this talk is going so well. So, OK, to do this, I'm going to need to delete the use state, of course, because we don't just want the number to go up only on clicking the button. We want it to go up every time the button re-renders. So to do this, I need to break some rules of React here. So don't try this at home. OK, so what did I do? So I added a ref to hold on to a number. And every time the component renders, we'll increment that number by 1. And then we just set the dislike count to whatever the number is. And this is pretty sketchy because it breaks one of the rules of React, which is to not read and write to refs during render, because it breaks the expectation that this component is a pure component. Now, some of you eagle-eyed developers may have noticed that when I added this code, we got a little red underline underneath our code. So here we have an example of a lint provided by the compiler. And it says, ref values to current property may not be accessed during render. But the compiler doesn't just warn us. It can also detect that we're doing something sketchy and then safely skip over this component and continue optimizing everything else. So let me take a look at the compiled output again, just to show you what happens. So I just enabled both of the features, like the visualization feature and the output. And so just to confirm, you can see that we no longer have the const dollar variable, which means the compiler isn't optimizing this component and left it untouched. And similarly, on the left, we no longer have our little sparkly emoji. So that kind of sucks, right? This component was being optimized before, but now it's not. But that's OK, because even though the compiler assumes that you follow the rules of React to optimize your components, you can also tell when you've broken the rules and then just skip over it safely. So let's just keep moving on and ignore this red line for now. Let me turn this off. So let me hit save. And we still need to fix our onPress handler because I just deleted the set dislike count. So what I want to do is whenever I click on the button, I just want to make it re-render. So to do that, we can add another use state. Wow, this tooltip is so big. And that should make it re-render. OK, let's go back and check on our progress. All right, cool. So now you can see that the dislike button starts at 1 this time, which, as expected, we increment the number when it renders. So it obviously starts at 1 when the page loaded. But now let's see what happens to this dislike count as we navigate around the non-compiled version. So I'm just going to jump around, go here, go there. Taking a while. So as you can see, it's kind of going up slowly. OK, well, yeah, it went up. So you can see that the compiler, or sorry, the application is re-rendering this button every time we kind of navigate around, which is really not nice, and we just don't like this. So I also want to show you what happens when I click on the like button. So maybe you can see this. Let me zoom in. Well, let me click on this a bunch. Call stack. That's no good. But you can see every time I click on the like button, the dislike count actually goes up by 3 times per like. So we really dislike this post. This is a terrible post. But I want to show you what happens in the compiler version. So let's just navigate around as well. I'll also click the like button. And yeah, awesome, right? So now some of you might be wondering, like, wait, didn't the compiler just not optimize this like button? So how come this is still 1? So remember that we broke a rule of React, right, in the dislike button, and so that we saw in the output that the compiler is no longer optimizing it. So the reason this is still optimized is because the post controls component, which is the parent of the dislike button, is still being optimized. And the compiler is adding the equivalent of React.Memo around all of the children of the post controls component. So even though this component isn't being optimized, we still get a lot of the benefits from using the compiler, which is really great. But if I go back to my editor and, what do we do about this red line? Because I don't know about you, but every time I see a squiggly red line underneath my code, I feel so compelled to fix it. And I can't, this is catnip. I'm like, ooh, a red line. And it's true, it can be really tempting to try and fix all of these rules of React violations that the ESLint rule detects. But as you also saw in the app, it's not strictly necessary to rush into fixing these if there are no bugs. Because again, the compiler can detect many cases of such violations and then just safely skip over it while continuing to optimize other components. And so if I turn back the Memo visualization, just to confirm, right, we don't have the sparkly badge. So if we want to, we can come back and fix this later, right? But for the sake of the demo, let's just say that we've already done that, and we're now coming back to fix this. So what can we do? So one thing we can do is to extract this code. So if I just delete this, you'll see that our sparkly badge immediately came back because the compiler saw that this code is no longer sketchy. So let's just add that back as a new hook. We'll call it useRenderCount unsafe. You can also call it useRenderCount do not use or you'll be fired, I guess, if you like that. So let's just add that back. And you can see that our red lines are back. But this time, it's just around the useRenderCount unsafe hook and not on my dislike button. And then let's just update this to use that new hook. And as you can see, we are still optimized. So hooray, we've made some progress, and we've helped the compiler compile a little bit more of our application. So that's really awesome. But how do we know that the compiler is memoizing correctly, right? How do we know it's just not holding on to the number 1 or 2 and then just caching that forever? So let me just refresh both tabs real quick to reset all the counts. So first, let's click on the like button here. And you can see that the dislike count doesn't go up. And so remember that the onPress handler for this button doesn't modify the count directly. It just triggers a re-render. So that means that the button is still correctly depending on the dislike count that comes from my sketchy hook. Let's also change the theme from light to dark. And you can see before I do that the count is currently 1. So let's change the theme from light. And I'm sorry, it's going to be really bright. Cover your eyes. OK, we're good. All right. So you can see the count went up to 2, and the thumbs down icon is the correct color. It flipped. So that means that the dislike count, or sorry, the icon is still reactive, and it still depends on the theme changing, and it does it correctly. Very cool. So let me switch it back to dark, and then you'll see that go back to 3 as well. All right, cool. So we verified that the compiler has memoized this correctly for us, and it only re-renders for the things that actually affect it. And we did that without writing any memo ourselves, which is really, really nice. But oh, by the way, if you remember, we still have our iOS simulator running. And it is not correct. I think my iOS simulator got disconnected. But anyway, the point is, because Blue Sky is an Expo app, and it runs on all platforms, the work that we just did will work on all of these platforms for free, which is really nice because I'm a pretty lazy developer. OK, so let's go back to our slides. All right, so I think you can see now that the compiler really helps React move closer to its vision of great developer experience that's easy to build and enables great user experience. And the compiler works on all platforms, on all modern React apps. So what we did earlier works on both the web and on mobile. And the compiler can also memoize far more effectively than we can do by hand, while also keeping that memoization resilient to code changes. If your code base follows the rules of React, adopting the compiler could be pretty straightforward. And as you saw, I didn't need to rewrite anything. There's no new APIs, because the compiler understands plain JavaScript and React. So let's recap. We just dropped in the compiler to all of Blue Sky without having to rewrite anything. And if you look at the PR to enable the compiler, it's a few lines of config and installing some packages. And we added a new feature to express our hate for this re-rendering without worrying about Memo at all. So that seems kind of easy. I promise I didn't script the drinking. OK, so it's easy because Blue Sky's code base follows the rules of React. But if you have a code base that doesn't, it might be a little bit more difficult and require debugging. And the rules that I'm referencing are the rules which some of you are probably quite familiar with. But it's OK if you're not, because you can check out the link above, and you can find out more about these React rules. These rules don't just help you write better React, but they also help you create a safe space for the compiler to optimize. And it's really important to follow them if you want a better quality application, but it also makes it easier to adopt the compiler as well. And as we also saw in the demo, the compiler also ships with an ESLint plugin. So that surfaces the compiler's diagnostics right inside of your editor, which is really nice. Because it's the first time we've been able to show rule of React errors in your code. The current React ESLint rules only show you the rule of hooks, which is only a subset of our rules. As part of the release, we're also including a health check script, which will give you a little sense of how much effort it'll take to adopt the compiler. It's not perfect, of course, but it can give you some signal into whether this might take a few days or a few weeks of effort. So some of you might also be wondering, how exactly does the compiler just work out of the box on any React app? How do we trust it? You don't need to know the theory behind the compiler to use it, but I think it's important to build an intuition for what it's doing. So let's build this intuition by first looking at how we do manual memoization today. So in today's React, when a component state changes, React is going to re-render that component and all of its children. And this sounds like a lot. And in practice, React is usually fast enough that most of the times it's fine to just re-render. But of course, we all know that there are many occasions as well where re-renders can really hurt performance. So you don't have to understand all of this, but let's take a look at an example and see what the compiler figures out automatically. So first, there's a couple of values that don't have any dependencies. These are static, so they never need to be recalculated. Then we also have values that depend on the online count here, which is a value that comes from the hook in the first line. And here's something interesting. A value that's cached can also become a dependency of another value. Third, we can also have values that depend on the friends prop. And finally, the overall view of JSX that gets returned can also depend on values that are themselves reactive values. But forget all of those boxes, right? It's kind of confusing. So let's just look at the original code again. This is a really simple example, but it's such a pure description of what your UI looks like. So one way to think about the compiler is that it's an auto-reactivity compiler. React is too reactive sometimes because when you change anything, everything changes. The compiler now automatically adds just the right amount of reactivity, and it makes updates fast by default. So in React, you describe your UI using plain JavaScript values, and the compiler automatically takes care of reactivity and performance for you. So you can forget about reactivity, and what you're left with is just React. Yay. All right. Another case where you may also need memoization today is if you have expensive calculations. So for example, let's say that you, for whatever reason, need to synchronously process a really large amount of data on the client. And running this function takes a long time, so you don't want to run this repeatedly on every render. So it's really important to memoize this. The compiler also handles this, since you can see that this expensive calculation was used during rendering. And when you combine it with optimizing for re-rendering, this is where a really large part of the compiler's performance benefits come from. One thing to note with this example, though, the compiler doesn't memoize everything. It only memoizes React components and hooks. So I mentioned earlier that the compiler understands the rules of React, so ordinary functions which don't abide by those rules are out of scope for the compiler and should be memoized outside of React if they are expensive. So when you combine these two optimizations, automatically figuring out dependencies and reactivity to skip re-rendering, and memoizing expensive calculations during rendering, the React compiler gets us closer to React's vision, where you continue to work with plain JavaScript values that stay at just the right level of reactivity, making it easy to build great user experiences that start up fast and have responsive interactions. If you're interested in gaining a deeper understanding into the many different kinds of optimizations that we do in the compiler, please definitely check out Mofei and Sathia's deep dive tomorrow. It's going to be awesome. But our time together is coming to an end, so here's a slide that you can all tweet. So please check out our docs on the compiler, and I hope you have a really good time trying it out. While we wait for the slide to come back, so I also want to announce that we're launching a compiler working group. So we'd like to invite teams to join the working group to provide feedback so we can help you roll out the compiler. And obviously, we cannot help everyone at the same time. So please get in touch through the link above, and we'll reach out when we're ready to help. My name is Lauren. You've all been great. Thanks so much for listening, and enjoy lunch in ReactConf. Thank you.
ReactConf 2024 can be beat.